In the center of the lobule, of each lobule, is a vein known as a central vein. So this is what we're going to look at diagrammatically for the next few minutes. And this is probably one of the best diagrams that illustrates what we're looking at. May I erase the board? I'm going to kind of diagram some of this on.
Not yet.
Wait.
Okay.
Can you leave the right side up? Okay, so.
You're in the board or the screen? The board? Okay. So we have this six-sided structure. There would be another one over here, and another one here. Okay, and in the center of each is a vessel known as a central vein. So to kind of draw that down through our lobule. And so the blood flow is percolating past these liver cells known as hepatocytes. So our portal vein comes in, and we have branches of the portal vein running up each corner and sending off branches along the side. And there would be another one here. And another one here. And one here. And one here. So each corner of the lobule is going to have a portal vein. Okay? In addition, and that's the structure that you're seeing here, the bluish one here, and here. In addition, we're going to have a branch of the hepatic artery. And I'm not going to do it for all of them, but you get the idea.
For each lobule, one
Okay? So I'll put the bile duct up a little bit later. I want to focus on the blood flow right now. But that's a lobule, corners of portal triads. Each portal triad is shared between three lobules. Okay, so if we go back to this diagram here, so the corners here.
were shared by three.
So this portal triad is going to go this direction, and this portal triad here is going to share between these three, and so on. Okay? Yeah.
So essentially, they would each get their own. They're sharing the liver.
Right. Just like they share a border, they share the blood supply. Okay? So now, filling up, think of it as placed like we're going to stack a whole bunch of bicycle wheels on top of each other. All right, and the center hub of the bicycle would be the where we have the central vein. It's not quite in the center. A bit more over here. Okay. So now the blood from the portal vein and the splenic artery flow into wide capillaries towards the central vein.
Is that the splenic artery or hepatic artery?
Really?
That's a hepatic artery.
Okay, you said splenic artery.
Sorry. So we're going to have branches from here join together, and flow towards towards the central vein. Branches from these vessels are going to flow towards the central vein. So we have these wide capillaries flowing like spokes.
So the blood is mixed, is that why it's purple?
Yes. And so these vessels are known, they're wide capillaries, and so they're identified as sinusoids. It's mixed hepatic blood, it's mixed venous blood from the portal vein and arterial blood from the hepatic artery. Now, our hepatocytes then are going to be lined up to take out of the blood the nutrients that they need. So the hepatocytes are never more than 2 cells wide, because we're going to have a hepatocyte facing that that vessel, and a hepatocyte facing that vessel. Like the backs are against to each other. So, like we have right here, those can take material from the blood, and those can take material from that blood. So every hepatocyte's apical membrane is going to have access to the sinusoid.
What would you say?
They don't get smaller.
And what's the basal membrane attached to it?
Pardon?
What's the basal membrane attached to it? The apical membrane?
Well, I'll draw that larger in just a moment. All right, so now the blood flows through the sinusoid into the central vein. And the central veins join together and form hepatic veins and empty into the inferior vena cava. So when we were doing our cardiovascular system, can everybody see these words now, Gretchen? We were talking about the formation of the portal system, and the superior mesenteric and splenic veins join together to form the portal vein. So if we look at our blood flow, we're going to have portal vein plus hepatic artery. These come together to flow through the sinusoid. That then flows into the central vein. And the central vein then flows into the hepatic vein. And that flows into the inferior vena cava. So that's how we expose the hepatocytes and allow them to pick up the nutrients that they need. So we'll cover this a little bit more on Thursday when we talk about absorption. But essentially, the portal vein, because it's coming from the small intestine, is going to be rich in amino acids and monosaccharides like glucose and fructose. The hepatic artery is going to be rich in oxygen and lipids, because when we digest lipids, as we'll see on Thursday, we'll talk about why, they go into the lacteals. And the lacteals go into the subclavian vein, which goes to the heart, which goes out the aorta after it goes to the lungs, and so the lipids are in the arteries. So the liver, being the biggest gland, gets first dibs at the amino acids. It makes clotting proteins, it makes albumin, it makes transport proteins for iron transferrin to carry iron. It stores glucose as glycogen. It also stores fat-soluble vitamins. And so it makes sense that the blood goes through the liver first. Before we look a little bit more closely at the relationship between the hepatocytes and the blood, we have a unique cell within the blood. What color do I want this one to be? We'll make it pink, which is a macrophage. It's a liver